The Hoover Dam is a 900-foot-tall battery holding back the American Southwest, and that battery is dying. For nearly a century, it has tamed one of the world's most unpredictable rivers, turning water into light for millions. It was a monument to what a nation could build. A symbol of control. But the water that gives it power has been steadily disappearing for 2 decades. The pressure is falling. The turbines are slowing down. Right now, the dam is operating nearly a third below its maximum capacity. That is not a forecast. That is a fact. And if the decline continues, the lights could go out. Not a brownout, not a rolling blackout, a permanent shutdown. Before we go any further, I have a question for you. What's the single biggest source of power for your city? A lot of people don't know. Let me know in the comments. The story you're about to hear is about more than a dam. It's about a system on the verge of failure. A shocking number of people watch these documentaries and find them valuable, but forget to subscribe. If this is the kind of story you want to see more of, please hit that subscribe button now. It's the single most important way to support the channel and ensure we can keep making them for you. It takes 1 second. Alright, let's begin. The Hoover Dam was never supposed to be just a dam. It was an act of defiance, an answer to the Great Depression, a concrete fist punching back at nature and economic collapse all at once. In the early 1930s, as the nation's economy disintegrated, the government greenlit a project so audacious it bordered on fantasy. Build the largest dam in human history, in the middle of a barren desert canyon, to harness a river so violent it was known as the Red Bull of the Colorado. The challenge fell to a man named Frank Crowe, the chief engineer for a consortium of construction firms called Six Companies, Inc. Crowe was a legend, a man who lived by the motto, "Never say no to a job, no matter how tough." And this job was the toughest he would ever face. The Black Canyon of the Colorado River was an unforgiving place. Summer temperatures soared past 120 degrees Fahrenheit. The canyon walls were sheer, treacherous cliffs. The river itself was a monster, prone to flash floods that could wipe out years of work in a single afternoon. To build the dam, Crowe's crews first had to divert the entire Colorado River. They blasted 4 massive tunnels, each 56 feet in diameter, through the solid rock of the canyon walls. It was a brutal, dangerous process. Carbon monoxide from the truck exhausts filled the unventilated tunnels, leading to sickness and death. But the work never stopped. Crowe ran the site 24 hours a day, 7 days a week, pushing his men and his equipment to their absolute limits. Then came the concrete. The dam required a volume of material so vast it defied easy comparison, over 3.25 million cubic yards of concrete, enough to build a 2-lane highway from San Francisco to New York City. But you couldn't just pour it all at once. The chemical reaction of concrete curing generates immense heat. A single, continuous pour would have generated so much heat that it would have taken over 125 years to cool, and the resulting stress would have cracked the entire structure into pieces. It would have failed before it was even finished. So Frank Crowe and his engineers devised a solution as ingenious as it was massive. They built the dam not as a single monolith, but as a series of interlocking concrete blocks. And inside those blocks, they embedded a network of steel pipes, over 582 miles of them. It was a giant circulatory system. They pumped icy river water through these pipes, drawing the heat out of the curing concrete, essentially building a refrigerator the size of a mountain. It was an engineering feat that had never been attempted at this scale, and it worked. The dam was completed in 1936, 2 years ahead of schedule and under budget. A titan of steel and concrete, ready to hold back the river and fuel the growth of the American West for a century. It seemed perfect. It seemed permanent. It was not permanent. It was never meant to be. Because the entire magnificent structure, all the concrete, all the turbines, all the power lines stretching out into the desert, was built on a mathematical error. A single, catastrophic miscalculation made a decade before a single worker ever set foot in Black Canyon. And that error is now coming due. Is it possible that the entire modern history of the Southwest was built on a foundation of wishful thinking? Let me know what you think in the comments. The year was 1922. Representatives from 7 states gathered to sign a document called the Colorado River Compact. Its purpose was to divide the river's water, to allocate a finite resource among a growing population. They agreed to portion out 15 million acre-feet of water per year, An acre-foot is the amount of water needed to cover 1 acre of land with 1 foot of water, about 326,000 gallons. A number so large it becomes abstract. The compact was a gentleman's agreement to share the river's bounty. The problem was, the bounty wasn't real. The river's flow was measured during an abnormally wet period in the region's history, a handful of decades that we now know were some of the wettest in the last 1,200 years. The average flow of the Colorado River isn't 15 million acre-feet. It's closer to 12 or 13 million, sometimes less. The system was designed with a structural deficit from day one. It promised more water than nature could deliver. For decades, this didn't matter. The massive reservoirs of Lake Mead and Lake Powell, the second largest reservoir upstream, acted as giant savings accounts. One wet year could cover the deficit of a dry one. The system had a buffer, but starting in the year 2000, that buffer began to disappear. The American Southwest entered a period of intense, prolonged drought. A megadrought, supercharged by climate change, that has now stretched for more than 2 decades. Rising temperatures mean more of the Rocky Mountain snowpack, the river's primary source, evaporates before it can even melt and reach the river. The soil is drier, so it soaks up more runoff. The air is hotter, so more water evaporates directly from the reservoirs themselves. Around 1.2 million acre-feet of water, 4 times Nevada's entire annual allotment, simply vanishes into the desert air every single year. The result has been a slow, steady, relentless decline. If you visit Lake Mead today, you can see the story written on the canyon walls, a stark white band of mineral deposits, a geological scar tracing the high water mark. This bathtub ring is over 150 feet tall. That is the height of a 15-story building. That is how much the lake has fallen from its peak in July of 1983. That is a reservoir hollowing out from the inside. This isn't just an aesthetic problem, it's a physics problem. The Hoover Dam generates electricity through hydropower. Water from the lake flows through massive pipes called penstocks, spinning 17 giant turbines. The amount of power it can generate is directly tied to a principle called hydraulic head. It's the vertical distance between the lake's surface and the turbines. The higher the water, the more pressure, the more force pushing on the turbines, and the more electricity they can generate. As Lake Mead drops, the hydraulic head decreases. The water has less force. The turbines spin slower. The power output dwindles. The dam becomes a weaker and weaker battery. The dam has a maximum power capacity of 2,074 megawatts, enough to supply power for an estimated 1.3 million homes across Nevada, Arizona, and Southern California. But at today's water levels, around 1,074 feet above sea level, its capacity is down by roughly 500 to 600 megawatts. That is the equivalent of a large natural gas power plant being switched off. Power that cities and industries have relied upon for generations is simply gone. If this story is hitting you, do us a favor and hit the like button. And if you have family or friends in the Southwest, or anywhere that relies on a single fragile resource, share it with them. This is a story everyone needs to understand. Water managers have 3 numbers that they watch with a kind of religious terror. The first is 1,229 feet. That's the elevation of Lake Mead when it's considered full, the system working as intended. The second number is 950 feet. This is the minimum power pool elevation. Below this level, the water pressure is too low to spin the main turbines. They can still generate some power with smaller units, but the dam's ability to function as a major regional power source effectively ends. 950 feet is the line where the lights start to flicker. The final number is 895 feet. This is dead pool. At this elevation, the water level is below the lowest outlet in the dam. Water can no longer flow downstream to supply California, Arizona, and Mexico. The power is gone. The water is gone. The Hoover Dam, the monumental symbol of humanity's command over nature, becomes nothing more than a concrete plug in a canyon, holding back a stagnant, inaccessible pond. In the summer of 2022, Lake Mead's water level fell to a terrifying 1,040 feet, its lowest point since the reservoir was first filled in the 1930s. It was just 90 feet above the minimum power pool. It was 145 feet above dead pool. The unthinkable was no longer theoretical. It was on the horizon. The crisis forced a confrontation that had been simmering for a century. For decades, the states had kicked the can down the road, relying on full reservoirs to mask the fundamental error of the 1922 Compact. Now, there was nowhere left to hide. In June of 2022, the federal government issued an ultimatum. The commissioner of the U.S. Bureau of Reclamation, Camille Kalamlim-Touton, stood before the Senate and delivered a message that sent shockwaves across the West. She said the 7 basin states had 60 days to come up with a plan to voluntarily cut their water use by an astounding 2 to 4 million acre-feet. If they didn't, she warned, the federal government would impose cuts itself. It was an unprecedented threat, the federal government telling sovereign states how much water they could use. The states scrambled. The negotiations were brutal. The battle lines were drawn along a century of water law, where your rights depend on when you claimed them. The Imperial Valley in Southern California holds some of the oldest, most senior water rights on the entire river. They are legally entitled to more water than Arizona and Nevada combined. Arizona, through its 336-mile-long Central Arizona Project Canal, holds junior rights. That means in a shortage, they get cut first and hardest. Nevada, with the smallest allocation of all, was already a world leader in water conservation. John Ensminger, the head of the Southern Nevada Water Authority, put it bluntly. He said the system had propped up an economically unsustainable agricultural system in the desert. He called the century since the 1922 Compact a century of magical thinking. The fight exposed the uncomfortable truth of the Colorado River. About 80% of its water doesn't go to homes, pools, or golf courses in cities like Las Vegas or Phoenix. It goes to agriculture. Much of it to grow water-intensive crops like alfalfa and hay, which are then used for cattle feed, some of which is exported overseas. The West was using a disappearing river to grow food for cows in other countries. It was a system that made sense when water was believed to be infinite. In a world of shrinking reservoirs, it started to look like madness. The states missed the 60-day deadline. The finger-pointing was intense. But as the lake continued to drop, a strange consensus began to emerge. The alternative to a deal was chaos. Lawsuits that could drag on for years while the system collapsed. Finally, in May 2023, California, Arizona, and Nevada announced a landmark deal. They agreed to voluntarily conserve 3 million acre-feet of water through 2026. In exchange, the federal government would pay them over $1 billion from the Inflation Reduction Act. Essentially, the government paid farmers and water districts not to use water they were legally entitled to. It was a temporary truce, a multi-billion-dollar band-aid on a gaping wound. It pulled the system back from the brink, but it didn't solve the underlying problem. The river was still over-allocated, the climate was still getting hotter, and the temporary deal was set to expire in 2026. As the water receded, Lake Mead began to give up its darkest secrets. The dropping shoreline didn't just reveal old foundations and submerged roads. It revealed bodies. In May of 2022, boaters discovered a rusted metal barrel stuck in the mud. Inside were the skeletal remains of a man. Police investigators believe it was a mob hit from the 1970s or 80s, a victim dumped in the vast, deep lake, never meant to be seen again. Then another set of remains was found, and another, and another. The shrinking reservoir had become a grim, unplanned archaeological dig. Each discovery was a macabre testament to just how far the water had fallen, exposing secrets that had been submerged for half a century under hundreds of feet of water. The lake wasn't just losing its volume, it was losing its ability to hide the past. While the politicians argued, one city had been quietly preparing for the worst-case scenario for years. Las Vegas, a city of 2.3 million people in the middle of the Mojave Desert, gets 90% of its water from Lake Mead. Its survival is tied to that single, shrinking source. The city's water managers at the Southern Nevada Water Authority, led by John Ensminger, had been watching the numbers and knew they couldn't rely on hope or politics. They needed an engineering solution, a last line of defense. The problem was that the city's 2 existing water intakes, built in 1971 and the early 2000s, were positioned at 1,050 feet and 1,000 feet of elevation. As the lake fell below 1,050 feet, the top intake was becoming dangerously exposed, at risk of sucking in air and damaging the pumps. They were built for a 20th century lake, and the 21st century was draining it dry. So they undertook one of the most audacious and expensive municipal water projects in American history. They decided to drill a new intake, not just a little lower. They would drill it at the very bottom of the lake. They called it the third straw. The plan was to drill a 3-mile-long, 20-foot diameter tunnel through the solid rock beneath Lake Mead itself, connecting to a new intake structure positioned at an elevation of 860 feet. That number is critical. It's below dead pool. It's so deep that it can pull water even after the lake has fallen too low for the Hoover Dam to operate. It was a plan to ensure Las Vegas could keep drinking, even if the lights went out. The project cost $1.5 billion. It took 7 years. A massive tunnel boring machine chewed its way through the earth, hundreds of feet below the bottom of a lake, holding trillions of gallons of water. It was a high-stakes, high-risk endeavor. The engineering was a modern marvel. Completed in 2015, the third straw was a lifeline, a desperate, brilliantly engineered bet on survival. It wasn't a strategy for growth, it was a strategy to prevent extinction. The city of Las Vegas had essentially built itself an emergency drain at the bottom of the bathtub. But the unavoidable, terrifying question remained. What happens when the bathtub is empty? The completion of the third straw revealed an uncomfortable dynamic. A city had spent billions to secure its own water supply, while the larger systemic problem of overuse across the basin remained unsolved. Was this the future? A world where the richest communities could afford to engineer their way out of a crisis, leaving others behind? Hey, just a quick reminder, if you're finding this story as stunning as we did, and you haven't subscribed yet, this would be the perfect moment. We pour everything we have into these deep dives, and your support makes it possible. Okay, back to it. The winter of 2022-2023 brought a shocking and temporary reprieve, and series of atmospheric rivers slammed into California and the Rocky Mountains, dumping record-breaking amounts of snow. The snowpack in the upper Colorado River Basin, which feeds the river, soared to over 160% of its average. As the snow melted in the spring, a surge of water flowed down the Colorado. Lake Powell, the upstream reservoir, rose by over 50 feet. Lake Mead rose by more than 20 feet. For the first time in years, the headlines were about rising water, not falling water. The immediate crisis was averted. The federal government, which had been threatening to impose its own cuts, backed off and accepted the state's voluntary 3 million acre-foot conservation plan. But scientists like Brad Udall at Colorado State University urged extreme caution. One good year, they warned, does not erase 20 years of drought. The system was still deeply in deficit. The lake remained more than 150 feet below full pool. The fragile recovery was built on a weather anomaly, a lucky break in a climate trend that was still pointing relentlessly toward a hotter, drier future. The 20-foot rise was a single deep breath for a system that was still slowly suffocating. The relief felt real. It was also an illusion. And now, the real battle begins. The temporary agreements, the emergency funds, the voluntary cuts, all of that expires at the end of 2026. The 7 states and the federal government are now locked in intense, high-stakes negotiations to write new rules for a new era. How do you divide a river that has fundamentally less water than it did 100 years ago? Every faction has a different answer. The lower basin states, California, Arizona, and Nevada, have proposed a plan where future cuts are based on a combination of water rights priority and contributions to evaporation and system losses. This is a direct shot at California's Imperial Valley, which, because of its location in a hot, low-lying desert, loses a huge amount of its massive allocation to evaporation. The upper basin states, Colorado, Wyoming, Utah, and New Mexico, have a different plan. They argue the primary responsibility for cuts should fall on the lower basin, which uses the majority of the water. The division is deep. It's a fight over history, economics, and physics. Who should pay the price for the original sin of the 1922 Compact? The farmers with senior rights who have built their entire livelihood on a legal promise? Or the sprawling cities that grew exponentially, assuming the water would always be there? There is no easy answer. There might be no answer at all that everyone can agree on. The federal government will likely have to step in and impose a solution that will inevitably end up in court for years. The Hoover Dam itself stands as a silent witness to this unfolding human drama. Its concrete is as strong as the day it was poured. the structure is not going to collapse. That's a common misconception. The danger is not a catastrophic failure of engineering. It's a slow, quiet, operational failure. A system's collapse driven by a lack of the one resource it cannot function without: water. Paleoclimate research, using data from tree rings, reveals a disturbing history. The Colorado River Basin has experienced droughts in the past that have lasted for 30, 40, even 50 years, far longer and more severe than the megadrought of the last 2 decades. What if the drought that brought Lake Mead to the edge of disaster wasn't an anomaly? What if it was just a preview of the new normal? What if it was just the beginning? The third straw was built to reach water no drought in recorded history could touch. But our recorded history is just a tiny sliver of the region's climate story. We may be entering a chapter for which no amount of engineering is prepared. I know, it's the third time, but a huge number of people watch right to the end and still forget. It really matters. Hitting that subscribe button genuinely keeps this channel alive. It takes 1 second. Thank you. The crisis of the Colorado River is a warning. It's a stress test for our future, not just in the American West, but globally. It's a story about what happens when population growth, a changing climate, and a century of flawed assumptions collide. The Hoover Dam was a monument to humanity's ability to control its environment. But the coming century will be defined not by our ability to control nature, but by our ability to adapt to a nature that is fundamentally changing beneath our feet. The dam was built to tame a river, and for a while it did. But what happens when the river itself begins to vanish? The engineering marvels of the 20th century stand ready. The turbines are waiting. The transmission lines stretch for hundreds of miles, ready to carry the power. But they are all connected to a battery that is draining faster than it can be recharged. The concrete may last for